Thank you for coming and welcome to another episode of Micrel TV. My name is Brian Huffman. I'm a product definer here at Micrel. And in this tutorial, we're going to talk about Micrel's latest innovation, the MIC23099. First, I'm going to highlight the features by first showing a demo and then going into the details. The MIC23099 is a single cell PMIC. It's one of the most integrated, high-power, single-cell PMICs on the market today. What makes a PMIC different than just a standard boost converter? It has more features. It has two outputs, a buck and a boost. It also has battery monitoring, battery status, and most important, battery protection, all in a 2.5 by 2.5 millimeter package. I can talk about the MIC23099 specs, but to give you a better idea, I built an LED flashlight with a boost converter of the part. Now, this wasn't the killer application this part was intended for, but it does demonstrate many of the key features of the part. And it's pretty cool. Let's go take a closer look.
When I turn the light on, the first thing you notice is how bright the LED really is. Here the LED is running at 100 milliwatts. That's only 25% of the total available power the MIC23099 can provide. The boost regulator is rated to deliver up to 400 milliwatts of output power from a single alkaline battery. The boost will provide a constant output voltage over the battery range of 0.85 volts to 1.6 volts, which will run the LED at a fixed brightness. Let me show you the battery status feature next. The red LED provides a battery status indicator. When the LED is on, this indicates the battery voltage is above 1.2 volts. When the LED is blinking, this means that the battery is getting low and it is time to replace. As an engineer, I feel that the most important feature of this part is its output short circuit protection and latch off. Let's say the product got dropped down a flight of stairs, or thrown at a wall, or even gets dropped into a swimming pool, and the PC board got damaged. At some point, the user is going to turn on the appliance to see if it still works. Without short circuit protection and latch off, the unit may overheat or worse. Let me demonstrate this key feature. I'm placing a shorting jumper across the output. Notice that even though the output is short, there is zero current being drawn from the input supply, and the IC protects itself. That was fun. Now let's dive into some of the details. The MIC23099 is like no other single cell boost Micrel has offered in the past. What makes this part so special is its high level of integration. Here's its application schematic. Its boost output is capable of 400 milliwatts of output power. It has both a high power mode and a low power mode to optimize efficiency. The buck input is internally connected to the boost output. The buck is capable of 30 milliamps of output current. The power good output is used to signal the SoC that the supply rails are up and ready. The MIC23099 also provides battery monitoring and a low battery indicator. The battery monitoring circuitry looks at the voltage on the input voltage pin. If the input voltage is greater than 1.2 volts, the LED is constantly on. Once the input voltage falls below 1.2 volts, the LED starts to flash, indicating that the battery is approaching end of life and needs to be replaced. Let's take a look at the efficiency performance. This is a logarithmic plot of the output current versus efficiency. The log scale allows one to see the efficiency performance over the entire operating range of the IC. Here, the efficiency for both converters exceed 90% over most of the output current and battery operating range. Another key feature is its small solution size. This IC is only 2.5 by 2.5 millimeters. The total solution area is about 100 millimeters square. This enables our part to be designed into many wearable products such as audio headsets and medical devices. The startup sequence control is built into the MIC23099. The boost regulator is powered up first when the input voltage is above 0.9 volts and the enable pin is high. The boost output ramps up slowly to reduce the voltage drop on the battery during this period. Once the boost reaches 92% of its final value, the buck output is enabled. The power good flag goes high 15 milliseconds after the buck reaches its final value. The power good output indicates that the power rails are up and ready. Minimizing both output noise and radiated noise was a big design challenge. Output noise is a major concern in precision medical devices and audio equipment. Higher noise levels can result in errors in measurements and noise in the audio band. RIC solve both of these design objectives. It is common to see multipulsing and output voltage of standard micropower boost converters. Here you can see multipulsing of our competitors' parts. These extra pulses dramatically increase the output noise. Here, the peak-to-peak ripple is 40 millivolts and is over 10 times higher than our part. This high ripple can couple into sensitive analog circuits. Our part has a patent-pending control scheme that allows 1 pulse per cycle, minimizing output noise. If you look closely at our competitor's switching waveform, you will notice a high-frequency noise on the switch pin. This noise occurs in PFM mode and is caused by the resonant tank circuit formation formed by the inductor and capacitance of the internal MOSFET. This increases EMI due to the large amplitude of the ringing. You'll notice in the Micrel part, there is no ringing. We have an anti-ringing circuit that senses this operating mode and eliminates the ringing.
This covers most of the key features of the MIC23099. For more information, go to the Micrel website at www.micrel.com. I really appreciate the time you took to join me here today. I'd like to know what you think, so if you have any questions, please don't hesitate to contact me here at Micrel. Thank you, and I hope you can join us again on a future Micrel TV webinar. Have a wonderful day.